This is the 7th section of the integration chapter, and here we look at partial fractions. So basically all this is using the method of partial fractions from chapter 1 to write an algebraic fraction in a form that we can integrate. So for example, if I was asked to integrate something like this, 6x squared minus 5x minus 2 or plus 5x minus 2 over x minus 1, 2x plus 1, for example. Now I'm not going to be able to integrate that directly, so what I do, I'm going to use the partial fractions which we learned in chapter 1 and convert it into something like this. So I know this one is actually 2 over x plus 3 over x minus 1 minus 4 over 2x plus 1 dx. Now we can integrate each one of these nicely, yeah, and for these ones we would actually, because of the pattern, and quite often with these, so often you'll get something of the pattern where it's like this, yeah. So you remember that we try log of the bottom, yeah. So for this term here I would try log x, then see if I need to make an adjustment here. I would try log x plus 1, or sorry, x minus 1, and so on, yeah. So there's an example like that. If I had repeated factors, so let's say for example I was asked to integrate something like this, so 11x squared plus 14x plus 5 all over x plus 1 all squared, so we've got a repeated factor here, 2x plus 1 dx. Now again, using partial fractions, let me just write PF for partial fractions, that would become an integration of 4 over x plus 1 minus 2 over x plus 1 all squared plus 3 over 2x plus 1 dx. So this part and this part we would use the reverse chain rule or the patterns. So we would like try here log of the bottom, we try log of x plus 1, see if we need to make an adjustment. Here we would try log of 2x plus 1, see if we need to make an adjustment. But for the one at the end here, or sorry, not the one at the end, one in the middle here, what we would do is we would write that. You can't try log of the bottom because of the square, that won't work. So we'd write it like this, so negative 2 x plus 1 to the power negative 2, and here we would use the reverse chain rule because the inside of the bracket is linear. So here we use the reverse chain rule. So you're going to pretty much find that once you've converted something into partial fractions, that the partial fractions that you have to integrate them, it'll either be trying log of the bottom, or it will be the reverse chain rule. Okay, and normally what you find is part A of a question is convert it to partial fractions, part B of the question is integrate it, hence or otherwise integrate that expression you started with. Right, so there are 3 here, so you've got lots of working. We'll try and make it as quick as possible. So the first one, we've got x minus 5 over x plus 1 x minus 2 dx. So we're going to convert that to partial fractions. So we're just going to take that expression that's there, and we want to write it in the form A. Now we can speed things up a bit. We don't need to write the whole working out. Now I would have written down a fraction which was A over x plus 1. So I need to multiply it by the other denominator, and then I would have had B, that would have been over x minus 2, and then I would have had to multiply it by the other denominator. Yeah, so we can just speed things up a bit because we know what we're going to get to. So from here we would start by saying, right, let x equal 2 to clear out the first bracket. So when x is 2, we would get 2 minus 5, which is negative 3 on the left hand side. The bit of the bracket which has a in front of it, that goes, and then we'd have 3b equals 3b. So then we've got b equals negative 1, and then we would let x equal negative 1 to clear out the other bracket. So that will be negative 1, negative 5, which is negative 6, or negative 1 minus 5. And then the second bracket and that will disappear. So we would have negative 1 minus 2, which is negative 3. So we'd have minus 3a, sorry, which means that a equals 2. So our integral now becomes integrating 2 over x plus 1 minus, because we've got minus 1, minus 1 over x minus 2 dx. So that's what we're going to integrate. Now what we do is we try log of the bottom. Now we're going to try and do that and do the differentiation check in our head and then do the adjustment. So we're going to try log of the bottom. So we know that it's definitely going to be log of x plus 1. Now when I differentiate that, I'll have 1 over x plus 1. I want 2 over x plus 1, so I'm going to put 2 there to make it balance. Then for the second bit, minus, it may change to a plus, we'll see. I'll leave a bit of space because I may need to make an adjustment. So we'll try log of the bottom again, log of x minus 2. So when we differentiate that, we get 1. So yeah, that's correct. We don't need an adjustment. So let's just move the whole thing over. Log of x minus 2. Didn't need the space. So log of x minus 2 plus c. Now we can leave our answer like that, or we can put the whole lot together as one log. I'll show you what I mean. So we could write the first thing as log x plus 1 squared minus log of x minus 2, and what we're going to do, we're going to write the constant as the log of something else. Let's call it the log of a. Yeah, that allows us to put all three together as a single log. So you'll have log of, the first bit is a division and then it's a multiplication, so it's going to be a, or we'll write x plus 1 squared. Now there's a big modulus around the whole thing. Actually we should put modulus here as well, just to make sure. So x plus 1 all squared plus or times by a, yeah, that's the other constant, divided by down here x minus 2. So it is possible to put it all as one expression. That is possible, right? That's the first one. Let's move on to part B. Well, that looks big. Right, so what have we got? 8x squared minus 19x plus 1 all over, we got a repeated factor here as well, 2x plus 1 x minus 2 squared dx. Right, let's see how much of this we can do in our head. So it's going to be 8x squared minus 19x plus 1 is equal to, right, so we're going to have a over 2x plus 1. That will need to be multiplied by x minus 2 all squared to get the right denominator. B will be over x minus 2, not x minus 2 squared, just x minus 2. So that will be, we need to multiply that by 2x plus 1 and x minus 2, but not x minus 2 squared. And then plus c, c is going to be over x minus 2 all squared. So that will need to be multiplied by 2x plus 1. So now we need to choose values for a, b and c to see if we can work them out, or choose values for x. Now remember, we need to also do comparing coefficients, because we're not going to be able to actually find a, b and c by just substituting values of x. So let's start, let's make x equal to, now let's see, if I make it equal to 2, that's an easy one to start with. So when x equals 2, I will get negative 5 from this. 8 times 4 minus 19 times 2 plus 1, that gives you negative 5. So negative 5. That will equal, now with 2, that's gone and that's gone. So we will have 5, 2 times 2, 4, 5c equals 5c. Equals 5c, so that means that c equals negative 1. Now the other value that I can make x is if I make x equal to negative a half, and that will clear off these two. So let x equal negative a half, and then we'll work that out and see what we get. Putting that on the calculator, that will give me 25 over 2 equals 25 over 4a, which tells us that a equals 2. Now let's just highlight these answers. There's a lot of work and easy to lose them. So c is minus 1, a is 2. Now what we need to do to find b, we need to compare coefficients. Because there isn't a number we can substitute in that's going to make the this part, the a part, and this part disappear, leaving us with b. So let's compare coefficients. We want to make it our working as easy as possible. So let's have a look. So we could compare the x squared coefficients. Yeah, let's do that. So we can compare the coefficients of the x squared terms. So on the left hand side we have 8. On the right hand side, when I multiply the brackets out, I will have ax squared. So I'll have a in front of x squared. Then I will have 2bx squared. So I'll have 2b, or not 2b. And then I will have, that will be it. Yeah, now I've already worked out a is 2. So 8 equals 2 plus 2b, which means that b must equal 3. So there we go. So just put that down there. So now, after all of that, our integration becomes integrating a, which is 2 over 2x plus 1 plus b, and b is 3, so plus 3 over, and that would have been the x minus 2 plus c, well, c is negative 1, so minus 1 over the x minus 2 all squared dx. So right, let's see if we can do this without too much going back and rechecking things. So for the first term here, we try log of the bottom. So that'll be log of 2x plus 1. Now when you differentiate that, you get 2 over 2x plus 1, so no adjustment needed. For the second term, we're going to try log of x minus 2, x minus 2. Now when I differentiate that, I'll get 1 over x minus 2, so I need to put a 3 in front here to make that work. For the last term, it's not trying log of anything. Remember, you move it to the top, so we're actually going to write this and think of it as negative x minus 2 to the power negative 2, and use the reverse chain rule. So that means integrating the outside, so that's adding 1 to the power and dividing by the new power. Now I may need to change this sign here, so I'm going to take that out for a minute. So adding 1 to the power, so that power becomes negative 1. We divide by negative 1, which actually then makes that a plus, so x minus 2, and then we multiplied by the inside of the bracket, differentiated, which is 1. So there we go. We could write that as 1 over x minus 2. So after all of that, here's our final answer: log of the bottom, 3 log of the bottom, and then the reverse chain rule to get that last part there. And of course, plus c. So put plus c here. Now remember, like last time, we could make that plus c part of the log by writing as log of something, but we're not going to. We'll just leave it like that for now. And we're on to the last one. Hopefully this isn't as much work. That was crazy. There was loads to do there in not a lot of space. Right, so c, this is the integral. Oh, this looks much nicer. 2 over 1 minus x squared dx. So the first thing I notice is that the bottom is the difference of 2 squares. So 2 over 1 plus x, 1 minus x. Okay, so I can see then my 2 factors. So changing it to partial fractions, so it's going to be the numerator 2 is going to equal the numerator of, it will be a over 1 plus x, so I'm going to have to do a times 1 minus x, plus, and then it will be b over 1 minus x, so b needs to be multiplied by 1 plus x. Yeah, so that's the quick way of doing it. So we're going to let x equal 1. So when x equals 1, we have 2 equals 2b, or not 2b, so b equals 1. If we let x equal, it's going to be negative 1. When x equals negative 1, we'll have 2 equals 2a, 1 minus negative 1, yeah, equals 2a, so a equals 1 as well. Nice and easy. So our integration becomes integrating a, which is 1, over 1 plus x, plus b, which is 1, over 1 minus x dx. Right, so just like before, we're going to try the log of the bottom. So we'll do the log of 1 plus x. Now differentiate that, you get 1 over 1 plus x, so that's fine. Plus then we're going to try the log of the bottom, so the log of 1 minus x. Now when I differentiate that, I will get negative 1 over 1 plus x. So actually that sign needs to be changed to negative 1, so that I end up with the right sign, plus c. Now we can put that together, and I will do that because I've got a bit of space. so that we can write that as the log of, because it's subtract, we think of it as a division, so we've got 1 plus x divided by, I hope these modular signs don't look like ones, 1 minus x plus c. And again, if we wanted to, you could write that as the log of something different, choose a different letter like a or whatever we like. Normally a, b, c, d we call our constants, and then that could be put together. Now just to avoid confusion, I'm going to put these modular signs in a different color, so you know they're modulus and they're not ones. Right, now here, this is an improper fraction. Notice the power at the top is the same as the power at the bottom. If the power at the top is the same or greater than the power at the bottom, then we have an improper fraction, which means we can't just go straight to partial fractions. We need to do long division first. So do long division first. That's going to be our first step to get that whole number out. So let's do that over here. So we've got 9x squared minus 3x plus 2, and we're dividing that by 9x squared minus 4. So 9x squared goes into 9x squared once, so that will give us 9x squared, I'll put plus 0x minus 4, shouldn't take too long to do, so we'll subtract that, so negative 3 minus nothing is 3x, and then that'll be plus 6. Okay, so what have we got? That this expression 9x squared minus 3x plus 2 over 9x squared minus 4 dx is actually equal to 1, the quotient, the whole number part, plus the remainder over the divisor. Now the remainder is negative 6 plus 3. Now what I'm going to do, I'm going to write it as plus, and then I'll write 6 minus 3x, just swap it around like that, over the divisor 9x squared minus 4 dx. So what does that mean? That means we just do partial fractions on this part, partial fractions on that part, and then it's going to be ready for us to integrate with the 1. Now the bottom part of that is the difference of 2 squares, so let's do it in red over here. So 6 minus 3x is actually that'd be 3x plus 2, 3x minus 2, so that's the difference of 2 squares. Right, so we will have 6 minus 3x, which is the numerator, equal to, now we're going to have a over 3x plus 2, so a is going to get multiplied by 3x minus 2, plus b, which is going to get multiplied by 3x plus 2. Right, so let's start. We're going to let x equal, it's going to be 2/3. So let's just work that out. So this will give me 4 equals 4b, which means that b equals 1. And then I'm going to say let x equal negative 2/3. That will get rid of the other one, and or we'll get rid of the b bracket. So let's work that out. Now that will give me 8 equals negative 4a, which then gives me a equal to negative 2. So our integral now becomes, down here, integrating 1 plus, it's actually minus, isn't it, because it's negative 2. Just rub that out. So 1 minus 2 over 3x plus 2, 3x plus 2 plus 1, that's b, and b would have been over 3x minus 2 dx. Right, so actually it's the partial fractions part, it's probably the hard part. The integration now is probably quite easy, so 1 integrated becomes x. For the second bit, we're going to try log of 3x plus 2. Now that will give you 3 over 3x plus 2. Now we want a minus. Now remember, there's a quick way of doing this. We've got a fraction, so it will give us 3. We don't want 3, we want 2. Yeah, so although this will give us 3 over 3x plus 2, we can make the top 2 by saying what number don't we want, we put at the bottom, what number do we want, we put at the top, and then the last part we're going to try log of the bottom, so log of 3x minus 2. That will give us 3 over 3x minus 2, so you could think of it this way: I don't want 3, I want 1. Yes, the number you don't want at the bottom, the number you do want at the top. So, and write that, plus c, it's done. Now, as with the previous examples, you can put those log terms together. I'm not going to on this one. You can if you want to, and you can check in the book if you get the same thing. I would only really put them together if the question stated they want the answer in a particular form. Other than that, I would leave it in that form. Right, you should now be able to do exercise 11G on pages 312 to 313. So remember, you're starting with some sort of algebraic fraction. Do you want to integrate algebraic fraction in terms of x? So what you do is you change it to partial. Actually, I could write it like this, couldn't I? Partial fractions. Oh, that's clever. Turn it into partial fractions, and remember the two things you'll probably do will be trying log of the bottom, make an adjustment, or it may be that you use the reverse chain rule, but you'd only use the reverse chain rule. That only really comes up where you've got repeated factors, which means you've got like x squared or x cubed at the bottom, which you can't do by doing log of the bottom. That's it.